Good morning to all of you. Myself Ankit Acharya, working as an assistant professor in Hasmukh Goswami College of Engineering, and today my content is GTU question paper solution of the subject of vector calculus and linear algebra of June 2010. So let's see. Question number 5A1 up to question number 5A1 we already seen. So here question number 5A, second part. Let T1 and T2 are linear transformation, where T1 is from set of 2 cross 2 matrices to R. T1 is defined from set of 2 cross 2 matrices to R, and T2 defined from set of 2 cross 2 matrix to set of 2 cross 2 matrix be the linear transformation. So T1 and T2 are both linear transformation given by T1 of A, where A is a matrix, capital A. This capital A is a matrix, right? And T1 of A is equal to trace of A, and T2 of A, that is equal to A transpose, right? So trace of A means sum of the main diagonal entries. Okay, so T1 of A is equal to trace of A, and T2 of A is equal to A transpose, where this capital A is a set of 2 cross 2 matrix. Now what we want to find composition of T1 with T2 of the matrix A, where A is equal to this capital A is equal to AB in 2 cross 2 matrix ABCD, right? So here is the solution. We want to find the composition of T1 with T2 of A. So that is equal to T1 of T2 of A, right? Now what is T2 of A? That is A transpose, right? T2 of A defined in the statement, that is equal to A transpose. So put the value T2 of A is equal to A transpose. So now you will get T1 of A transpose, right? So what is A transpose? What is A? A is ABCD. Now transpose of A, that means you have to interchange row and column. So this first row AB become the first column, and the second row CD become the second column. So here is the A transpose ABCD. So T1 of ABCD, that is equal to trace of ABCD, right? Now trace of ACBD, trace of this matrix, that means sum of the main diagonal entry, that is equal to A plus D. So our final answer is A plus D. So composition of T1 with T2 of the matrix A, that is equal to, you will get A plus D, right? And this question asked in 2 marks in this question paper. So next question. Question 5B. Find the matrix P that diagonalizes A, that is equal to 1 0 minus 1 2. Okay, and hence find capital A raised to 10. Also find the eigenvalues of A square. So just first of all try to understand the question. You want to find the matrix P that diagonalizes this matrix 1 0 minus 1 2, and hence you have to find A raised to 10, right? So directly to find A raised to 10, it's quite difficult. So for that we find eigenvalues, eigenvector. Using that eigenvector we can find the matrix P which is diagonalizes this matrix, and that matrix, using that matrix we will get the A raised to 10. So let's see how we solve this question. Also we want to find A square, eigenvalues of A square. Okay, so that is quite easy. See, now if you understand this matrix, this is lower triangular matrix, you can see, right? This matrix is a lower triangular matrix, and we know that in lower triangular or upper triangular matrix the main diagonal entries are the eigenvalues. So directly you can say that the eigenvalues of this matrix is 1 and 2. Okay, otherwise by this method we know that how to find eigenvalues of any matrix. We want to find the determinant of this equation, determinant of A minus lambda I which is called characteristic equation. The characteristic equation of A is determinant of A minus lambda I equal to 0. So determinant of A minus lambda I can be written as 1 minus lambda. Just you can see in main diagonal we have to add minus lambda. So 1 minus lambda, 2 minus lambda, other entries are same, 0 minus 1, that is equal to 0. Now 1 minus lambda into 2 minus lambda, that is equal to 0. Okay, determinant of determinant of this elements, that can be written as 1 minus lambda into 2 minus lambda minus 0 into minus 1, that is equal to 0. So 1 minus lambda into 2 minus lambda equal to 0. So that's why the eigenvalue of A are 1 and 2. Directly also you can say that the eigenvalues of this matrix is 1 and 2, because I already told you that the given matrix is a lower triangular matrix. So in lower triangular or upper triangular matrix, we know that the main diagonal entries are exactly the eigenvalues of the given matrix, right? So next we want to find the eigenvector corresponding to lambda is equal to 1 and lambda is equal to 2. So how to find eigenvector? Let x1 is equal to x1 x2 transpose be the eigenvector of A corresponding to the eigenvalues lambda 1 is equal to 1. The matrix equation A minus lambda 1 into I into x1, that is equal to 0, gives, see, in this matrix or in this determinant, we want to write the matrix form, but just put the value lambda is equal to 1 in this form. Put lambda is equal to 1, so you will get 0 here. This is also 0, minus 1, and this become 1, right? So 0 0 minus 1 1. So here same matrix 0 0 minus 1 1, x1 x2, that is equal to 0 0. Now from this equation you will get only one equation. You will get minus x1 plus x2 is equal to 0. Okay, so just randomly take x1 is equal to t, so x2 is equal to t, right? X1 is equal to t and x2 is equal to t, hence x2 is equal to t. Because of this equation, from this equation you can say x1 is equal to x2. So when you take x1 is equal to t, x2 is also t. So what is our eigenvector corresponding to lambda is equal to 1 1 1, right? T is a parameter, so 1 1 is our eigenvector corresponding to lambda 1 is equal to 1. Okay, now we want to find eigenvector corresponding to lambda is equal to 2. So another eigenvalue is 2. Put the value of 2 here, right? Put value 2 here. So 1 minus 2 you will get minus 1 0, then minus 1, 2 minus 2, that is 0. So you will get minus 1 0 minus 1 0. So this is a matrix minus 1 0 minus 1 0. This is just a basic funda that x2 is equal to, let y1 y2 be the eigenvector corresponding to eigenvalue lambda 2 is equal to 2, and the matrix equation A minus lambda 2 I into x2 is equal to 0 gives this matrix minus 1 0 minus 1 0 of y1 y2, that is equal to 0 0. Now from this equation you will get minus y1 is equal to 0, that means y1 is equal to 0. But about y2 you will not get anything, so you have to suppose y2 is equal to t, right? Okay, so y1 is 0, y2 is equal to t. So what is our eigenvector? 0 1. What is the coefficient of t in y1? That is 0. What is the coefficient of t in y2? That is 1. So that's why 0 1 is the eigenvector corresponding to lambda 2 is equal to 2. So this is a matrix P. See, the first column is the eigenvector corresponding to lambda is equal to 1. The first column 1 1, this is our first column, which is exactly the eigenvector corresponding to lambda is equal to 1. And the second column 0 1, which is exactly the eigenvector corresponding to lambda is equal to 2. So just you have to as a column vector you have to put the eigenvector, right? First column is eigenvector corresponding to lambda is equal to 1, and second column is eigenvector corresponding to lambda is equal to 2. So now we want to find a raised to 10. Next process is we want to find a raised to 10. For that, first of all, we have to find P inverse. Now this is P, which is a 2 cross 2 matrix. So to find inverse of this matrix, it's quite easy, right? What we have to do, first of all, find adjoint of this matrix, adjoint of P. What is our adjoint of P? Just interchange the main diagonal entries. So in main diagonal entries in this matrix, you can see both are 1, right? So when you interchange these two entries, you will get same 1 1, right? So this one become here and this one become here. So the entries are same 1 1, and you have to change the sign of the another diagonal. So 0 becomes 0 and 1 become minus 1, right? So what is adjoint of this matrix? 1 0 minus 1 1. So adjoint of this matrix is 1 0 minus 1 1, okay? And determinant of this matrix, you can see 1 into 1 minus 0 into 1, so that is 1. So determinant of this matrix is 1, which is not equal to 0. So that's why you can find the inverse of this matrix. P inverse exists. Adjoint of P, as I told you, we interchange the entries of the main diagonal here and change the sign of the another diagonal. So that's why you will get adjoint of P is 1 1 and 0 1 0 minus 1 1. Now what is P inverse? P inverse is adjoint of P upon determinant of P, but determinant of P is 1. So P inverse is exactly the adjoint of P, which is 1 0 minus 1 1. Now we have P inverse, and A is already there. So this is the equation diagonal matrix D, that is equal to P inverse AP. So this is P inverse. See, P inverse is 1 0 minus 1 1. So this is P inverse. First matrix is P inverse 1 0 minus 1 1. This is our A 1 0 minus 1 2. Okay, and this is P 1 0 1 1. When you multiply this 3 matrix, this 3 2 cross 2 matrix, you will get this matrix, right? Just simplify multiplication of this 3 matrices. It's quite easy, but directly also you can say that this capital D is actually the triangular matrix, okay, the diagonal matrix, in which the main diagonal entries are exactly the eigenvalues and another entries are 0. Okay, in P, you can see in P, what is first column? First column is eigenvector corresponding to lambda is equal to 1. So that's why here 1 in D. What is second column in P? The second column in P is exactly the eigenvector corresponding to lambda is equal to 2. So that's why here 2. So in main diagonal entries, you have 1 and 2. Other entries are 0, must be 0, because this is a diagonal matrix, right? So just try to understand. And when you multiply this 3 matrix, you will get also this diagonal matrix 1 0 0 2. So the matrix P 1 0 1 1 diagonalizes A, and the diagonal form of A is D 1 0 0 2. Now using this D, using this diagonal matrix D, we can find A raised to 10 easily, because of there is a formula. See, A raised to 10 can be written as A raised to 10 can be find using this method, P D raised to 10 into P inverse. Now we have P 1 0 1 1 D raised to 10. So D is a diagonal matrix. See, D is a diagonal matrix. So if you want to find the power of this diagonal matrix, it's quite easy, because the power of this diagonal matrix is exactly, if D is equal to diagonal matrix D raised to K, that is equal to, just in main diagonal entries you have to raise to K. So 1 raised to K, 2 raised to K. So in particular here we want to find D raised to 10. So what is our D raised to 10? This another diagonal entry must be 0, but in main diagonal entry you will get 1 raised to 10 into 2 raised to 10. So that's why here D raised to 10 can be written as 1 raised to 10 0 0 2 raised to 10. Okay, and P inverse, this is P inverse 1 0 minus 1 1. So 1 0 1 1 1 raised to 10 0 0 2 raised to 10. This is P inverse 1 0 minus 1 1 So now 1 raised to 10 is 1, 2 raised to 10 can be 2 raised to 10 is 1024. So multiply this 3 matrices. Okay, it's quite easy, right? So multiply this 3 matrices, 1 0 1 1 1 0 0 1 0 2 4 1 0 minus 1 1. Okay, let's try to check the multiplication of this 3 matrix. Okay, let's try to check. This is first matrix 1 0 1 1. This is second matrix 1 0 0 1 0 2 4. This is another matrix 1 0 minus 1 1. So let's try to check the multiplication of this 3 matrix. First of all, we multiply this 2 matrix, right? So this matrix is same 1 0 1 1. Try to multiply this 2 matrix. So first row, consider the first row and multiply with each column of the second matrix. So 1 into 1 1 into 1 plus 0 into minus 1. So you will get 1. Okay, then 1 into 0 plus 0 into 1. So you will get 0. Then 0 into 1 plus 1024 into minus 1. So that's why you will get minus 1024. Okay, and then 0 into 0 plus 1024 into 1. So you will get 1024. Okay, so now multiplication of this 2 matrix is, we will get this matrix. Now we want to multiply this